As of last year, we had about 1.5 million Ruby tests. And if you ran them on a single machine straight, it would take 2 months. So unfortunately, with my little change, I cannot afford to just go on holiday for 2 months and then find out if it worked.
Our next speaker comes from Stripe, and he'll tell us a little bit more about how it is to work there. James Carr.
Thank you. Please don't expect anything as well coordinated as that. But I would like to make it interactive. So this is going to be a little walkthrough through a kind of day in the life of a developer working at Stripe. I'm going to be talking about how it works, but I would love if people have questions as we go. If you raise your hand, I'm happy to answer them. I have a bit of time at the end for Q&A. But yeah, I just want this to be interactive and going to give you a perspective at how we work as a very large Ruby company. I'm going to start by kind of framing this a little bit. Does anyone here use Stripe? Yay, that's great to see. Cool. So who are Stripe? For those of you who don't know, I'll talk about that in a sec. And then who am I? So a little introspective. Professionally, I work at Stripe on our Ruby infrastructure team. So we have a very large Ruby code base, and we have a team dedicated to helping it scale, helping keep it clean, helping with our version upgrades, with our gem management. We're large enough now that we need a set of full-time engineers working on it, a whole team. But we find it's a great investment, and it helps scale the rest of our product org. And so we can kind of not have to give up Ruby because we got large. It's much easier to keep the same code base, scale the actual use of the language, as opposed to having to rewrite everything in a kind of more big org language. For anyone who doesn't know, so Stripe is perhaps most well known as a payments company. So we started back in 2009 or so as a simple way to accept credit card payments, and over time that had kind of good product market fit, so we expanded it to be more types of payment, and eventually people started wanting more features, so now we have like a funding service. You can apply for a kind of a short-term loan for your company, and you can pay it back as you go. We have a way to manage subscriptions. We have a way to manage your climate donations, so if you want some portion of your revenue can go towards offsetting carbon emissions. So there's like a whole suite of products, and they all are mostly built on Ruby. And so this is really about how do we take kind of one core product and then scale it to a kind of multi-thousand person org company. And then the framing for this talk is going to be a day in the life. So this is going to be kind of hopefully grounded in something quite normal, so nothing super exotic, and just seeing how does it work at a very large company. So let's imagine that I'm a developer working on a payments team, and I'm expanding country coverage in Europe, so we expanded into Romania. So like, great, I'm going to add, hopefully it's a one-line change, just add a new currency to our enum for tracking currencies that we have, and then we're like, done, hey, like new currency, everyone's happy. So I land this in production, it goes out, and I say like, all right, I'm going to make a little test transaction, I'm going to check the logs to make sure everything looked good, and I do that, and I say like, all right, so payment's conceded, the currency is correct, but the amount looks a little funky. We're not using dollars here. So maybe let's try and investigate what's going on, and we'll debug it, and we'll kind of fix the code base for everyone else as we go. So I start by saying like, all right, well, I see the string, successful payments, that's a good starting point. How would I go and find out what's actually broken? So I'm going to search the code base for this string. We have a nice internal tool where you can search all of the Ruby code base, which I think at this point is over 25 million lines in about half a second to find out this like this particular string. So we're going to search for that, and then hopefully that gives us a clue. And so we kind of track down. We're like, all right, this is where we're logging it, so we can see that matches. The currency, that was correctly rendered, but the amount, that was the funky bit. So I've got this open in my editor, and most developers within Stripe will use a VS Code. And we have Sorbet, which is our type checker, running in the background in a LSP, language server protocol mode. And that will tell us, that will give us kind of great features within VS Code. So that could give us, for example, jump to definition. So it knows that this amount is of this amount class, and there's something wrong with this pretty format method, so I can just click on that. It takes me to the definition of the method, and I hop to that, and I'm like, that makes sense. The last time we expanded country coverage was a little bit short-minded, short-sighted, and so they, it's a reasonable default, perhaps not correct in every case. So I would like to clean this up, so I want to fix it for Romania, and then I also want to make sure that this doesn't happen again, because I could definitely tack on another case up here, which is just handling Romania, and then that's it. the next person, when they expand into the Philippines or into, I don't know, Mexico, where they kind of render currencies differently, will have the exact same issue. So I want to fix this for everyone else in the code base. So we were using sorbet, and if we actually go back a second, we were using an enum, which is a feature we have within sorbet, and that gives us, again, like in Java, an enumerated set of values. And we find that super useful because it will tell us, like, these are all the possible permutations of this. So we could actually use that and hop back to our code, and we could definitely fix it for Romania. So like, hey, it's rendered correctly. You've got dollars as well. And we have this handy feature which would tell us if sorbet could figure out that there is a way in code that could reach this line, it'll give us a type checking failure and say, you didn't handle the case. So the next time someone adds a new currency, this will fail automatically and they won't go to production. You'll know ahead of time that it's already failed. You can't even merge your code into our main branch. And then that way you've saved yourself an entire deploy cycle, debugging, fixing it. You just get highlighted immediately like, hey, you added Filipino pesos. You forgot to add a case here. If you add it, it's very obvious. And so you might think like, is this really necessary? Could I just write a test to make sure that this is the correct format? In our case, we didn't even know that log, well, like where it was rendered. We didn't expect to see that. We just kind of saw that as we searched for the transaction. And that's kind of the point, which is a code base large enough, you just don't know the second, the third, the fourth order effects of your changes. And it's really helpful to have this to say like, hey, you might not have even been aware of this slice of the code base, but make sure that you handle it correctly and you kind of offload some of that mental load of trying to figure out, be very defensive about your changes. So we find this is an enormous productivity help for us. Kind of productivity keeps people happier because you don't have to keep so much in your mind. And then it also catches issues that might break in production. And time is spent, you're spending 5-10 seconds spotting this type checking error is way better than having to have code go into production, see it break, worry about what's going on, kind of roll it back, put out a fix, relaunch the service. So the further we can push that in the development cycle, the earlier we can push it, the better for everyone else's productivity, for everyone's happiness, and we don't want people to kind of get frustrated with the size of our code base and leave the company. And in my opinion, I think a type checker is not really about sparking joy or adding joy. For me, it's more about removing sadness. So stuff going into production that breaks makes me sad. I don't want to see that happen. If we could have avoided it, I don't want that to have occurred. If we can help make people's lives easier, help the onboarding process, if new hires make a mistake, it's harmless as a type checking error. If it goes into production, they would have a terrible first month experience, for example. So with the more we can push statically, the better everyone's development experience is. And again, it kind of makes your code base feel smaller because you don't need to know, again, all of these fourth order effects. You don't need to know how code of code is being used. You just assume you're working your little slice. You find out if there are failures. You handle them as they come up. And you didn't need to be aware of this stuff up until it was necessary. And I will say, we have a very large code base. We find it gives us tremendous value to have a type checker. If you're a one-person Rails shop, probably isn't worth it, I would say. It's not really worth having all these static definitions for your types. But if it were me starting from scratch, I would probably be using sorbet in typed true mode. So that would be the case where it would tell you hey, you might have refactored code, renamed a module, this reference doesn't exist anymore, you should go fix it. So it's very low overhead, and that's the kind of stuff that's obviously wrong. It's almost like a syntax error, and it's great to be able to catch that stuff as soon as possible. And then as your company grows, as your code base grows and you onboard new people, then you can kind of gradually add more types. But I think there was tremendous value in just having some base level coverage. Cool, all right, so I made that change to add the Romanian case and add exhaustiveness so that we know that we're not gonna have this kind of failure again. And I work on Git on my laptop or my kind of remote Linux machine, and I push that change up. And that goes to our internally hosted GitHub, and then CI kicks off. So we have kind of a suite of different sets of tests. So we have some consistency things, which again are of that spirit of it's a massive code base and we don't want it to feel like 1,000 tiny small code bases. We'd rather it just feels very familiar. So we have a Ruby format that we wrote. It's on GitHub. I would encourage you to use it. It's kind of it's written in Rust and it's super, super fast at editing your Ruby source code. We have it as a CI check to make sure the entire code base is consistently rendered or consistently formatted, and Robocop to catch any kind of obvious mistakes. Again, the further we could push it in the earlier in the development cycle, the better for everyone's experience. And then we start running CI, and then we start running the tests. And there are a lot of tests. I think as of last year, we had about 1.5 million Ruby tests. And if you ran them on a single machine, straight, it would take 2 months. So unfortunately, with my little change, I cannot afford to just go on holiday for 2 months and then find out if it worked. I think the company expects more of me. So we have to be smarter about that. And you might say, okay, so you have this many developers, and you're running kind of 60 days worth of tests for every change. Why would you do this? If you just had a bunch of smaller repos, then you could keep the changes more local, and you wouldn't test as much. We find, at least, that you get tremendous productivity benefits from having everything in one code base. And it's far easier to solve those problems of scale with a single team focused on that, or maybe a few teams, as opposed to pushing their responsibility to everyone who works in product to say, like, your service should go put in the new version of the currency library. So that's a version bump that you need to pull in because they might have other stuff going on. It's far better for us to just say, we're going to make an atomic change in the code base. Everyone gets it all at once. I never have to worry about kind of, your version is out of sync. It's just all completely clean. And so we find that's great for us. Again, your scenario might be different, but we find, at least as we've gotten bigger, it's actually gone better and better and better. At this point, we're kind of trying to eventually consolidate on one repo within Stripe, but that's going to take us another few years. But at this point, 99.9% of the Ruby code is in one code base, and we often make massive atomic changes. And it's really easy, and we have enormous confidence in it, because again, CI runs across everything. So if you just push that change up, you're very certain that it's going to work. And just to give you a kind of another idea of that sense of scale, those 60 days worth of tests. So you can imagine a graph which is, this is your developers over time. So the axes on these aren't too important. It's just kind of like the general trend that we care. And so if you imagine at some point you start and developers are writing tests, and then as you add more developers, they're writing more tests, but you've already written plenty of tests. And so the amount of tests that you have grows faster than your number of developers, because you have everything from you had before, and they're now writing more tests. And you might think like, all right, well, it's scaling, but it's not like horrible. You could just throw more machines at it. But this isn't actually what you care about, because what you care about is the product of these two things, because you have more developers who are writing more code, who are now running all of the tests that you have, and that's what you care about. And that graph doesn't look like this. It looks like this, where the developers over time is pretty tiny, and the amount of tests that you run cumulatively is absolutely massive. And this was a real issue for us. So this might look like an exaggerated graph, and maybe the slopes are a little steeper than they were for us, but this actually happened. And we were getting to a point where if we projected a few years out, it would have been kind of unpalatable how much we would have had to spend on CI to run our entire code base on every single change. So we had to get smarter, being more selective on what tests we run. So let's dive into how. Okay, so it's a little kind of simplified version of our code. Let's just pretend that this is how it works for now. So I made a change in Romanian tests, and that depends on some kind of common platform, which is also used by other payment methods, and maybe there's a bunch of other countries here, and that payment method platform depends on accounting. It probably depends on a bunch of stuff, but there's like a nice kind of hierarchy of how the code calls itself. And then there's like another slice of the code base, which is completely independent, and it has its own changes. And so what we can do is, or what we do is, when we run these tests, we look at the open syscalls that happen within Linux, and we end up tracking this test, what are all the files that it reached while it was executing. And we build up a giant list that says, like, this test maps to all of these files. And we do that for every single run on CI. And then when we want to be more selective, what we care about is the inverse of that mapping. And so we could say, like, all right, well, you changed this class, and I know now, kind of working the reverse dependencies, what tests could possibly have been executed by that. And since we're intercepting the open syscall, when you require a file in Ruby, that is an open of that other Ruby file to read it. So we have really high confidence that, for example, if there's no link between accounting and Puma wrapper, which hopefully there isn't in our code base, then if you change this, there is no possible way that this bit of code is affected, because there is no relationship between those two bits of code. So in this example, though, if I change something in the accounting package, I know, like, all right, if I walk back up the tree, what are all the possible tests I run? And that's a really high signal, useful for us to say, like, I can just discard everything that possibly could not have been reached. And that's what we do on our kind of main branch CI. But for feature branches, which make up the majority of CI runs for us, because developers will make a little change, get feedback from CI that something broke, push again, they get feedback from up here when they try to get reviews, they push again. So that makes up the majority of our CI builds by count. We're actually even more aggressive than this. And so in this example where we're looking at accounting, we don't go back the entire way. We actually end up kind of short-circuiting about one level deeper. The idea being, your dependencies probably care about changes in your behavior, but your dependencies probably wouldn't even notice. Hopefully you don't have to go, like those details aren't being leaked that high up. And so we do this, and we can cut down about 99.5% of the tests that we would run. So we go from 1.5 million down to about 1,000 or 2,000. And we end up saving obviously an enormous amount in CI, because that's just such a massive reduction. And it gives developers feedback faster. And we have a 1%-ish flake rate. And so we found that's a very acceptable trade-off for us between how much money we save and the the bad experience where you made a change, it seemed to pass on your branch, but then when you try to merge, it fails on your main branch build. So for us, this completely bent the curve. So instead of looking like, it did here, whereas now, the product of, the number of developers you have times the number of tests, it's more proportional to just the number of developers that you have. And that's a much more acceptable number for us. As we grow our headcount, our tests grow proportionally, and that's totally fine, because tests aren't actually that expensive on a per human basis. What's really expensive is running all of CI, every push, every time, because that number grows massive. We do some cool stuff as well for how we provision the test runners. So we have a fully elastic set of worker pools. So we vacuum up a ton of Amazon Spot instances, and we can scale really, really high fidelity with the developer load. So as, for example, people in the US wake up in the morning, they start pushing their changes, we'll ramp up the number of CI workers that we have. We dip at lunch, because few people are testing at that point, and we ramp up in the afternoon. And then by the nighttime in the US, so when that's the maybe morning in Europe or the afternoon in Asia, we have a lower baseline because we have more developers in the US, but it's super responsive, and it means that we don't really waste a ton of money having these these test runners available that aren't being used. All right, so you made your change, CI passed, all the lints are happy, tests are looking good, so now you want to merge your code. So at our scale, we found that there was a pattern that was happening where you had a branch that you opened up, and it was maybe from 2 weeks ago, you went on holiday, you had a stamp, and then you try to merge it, and there's no merge conflicts. So syntactically, there is no conflict with another file. But in the meantime, someone else might have made a change to some code underneath you that maybe rendered your assumptions incorrect. And so your test passed 2 weeks ago, they would fail now. If you merge that code and we run it on our main branch, it's going to blow up and everyone's going to be blocked on deploying. So we have this feature that we call integration branches. So when you hit, I'm ready to merge, we take your diff, we stack it on top of the latest version of our main branch that passed tests, we rerun CI, and then we merge it if it's correct. And that takes the race window from 2 weeks indefinitely down to about 5 minutes, and it's pretty much never happens that someone would have an issue. And if they did, they would just rebase, try again, and it would work that time. And we find that's, again, we're able to cut out a massive amount of tests, because the difference between your main branch that just passed tests and what you're about to change is actually a very small set of files. It's really whatever was in your branch, as opposed to all of history for the last 2 weeks. And then we take these integration branch builds, and when they pass, we just tack on another commit onto our main branch. So we don't have a super messy, New York subway style Git history anymore. It's just perfectly linear for the last several years. So if you ever had to bisect, it's the dream case of everything is just in a line. And if you want, you can even use a feature that I find super useful, where you put up your PR and you say, once everything passes, so CI passes, lints pass, I get approval from a teammate, then automatically merge in my PR. And that's great for me, because sometimes when I'm working UK hours and I get approval from someone in the US, it might happen overnight. So I can put my PR up that I feel confident landing, wake up in the morning, it's already merged, it's already deployed. I didn't have to do anything, but it passed all the checks that we need. So someone signed off on it, it was deployed successfully. So it's a great quality of life improvement. Then we queue them as well, because in our case, again, sometimes you end up where after lunch in the US, everyone wants to merge code, and suddenly you end up going from 0 load to several hundred developers trying to merge. And you need some queuing to ensure that you're not overloading our CI systems. Cool. Any questions so far? All right, there is a Q&A at the end as well. Cool. All right, so that was all testing, and that was super helpful for, again, bending that curve to ensure that we're not just hemorrhaging cash, spending money on test runners. But we need to deploy this code as well. And so the step that we have been investing a lot in more recently is our build system. So maybe 5 or so years ago, we started moving everything onto a self-hosted Kubernetes cluster. And at the time, it was our first experience with it, and so we made one big Ruby image, like container, which had all of our source code, and then effectively the union of all dependencies of all services that would run that container. So if we needed an imaging library, or if we needed like a PDF library, that kind of stuff, it would all be in there. And that was useless for pretty much every service. It's only like 1 or 2 that would care about those dependencies. So we're trying to move to a world where you specify a container per service, and if you want these additional dependencies, then you just tack them on to the build, and then your service pays the penalty, but you get value from it, whereas no one else has to suffer. And then the really cool thing that we can do is we can start, since we have a monorepo, we have access to all of the source code, we can start doing stuff like stripping out code that we know we can't reach. So for example, we have a payment service, it enters in the payments graph, and it starts saying like, what is all the code that I could reach? So payments could reach credit cards, which can read the database, but for example, there is no path from this entry point to admin tooling, because you can't walk backwards, it's only kind of as you traverse the graph. And similarly, there's no employees. And it's not just like 7 nodes in our graph, we're talking like thousands of packages and hundreds of thousands of files. And so you might think like, this is just source code, like how much could this actually be taking up? But we're making our package graph more precise right now, and we're saving on the orders of hundreds of megabytes from our compressed images, like compressed text. So like it really makes a difference, and you might think like, oh, it's just text, but like it adds up after a while. And that means that we have faster builds, faster deploys, because it takes less time to download, and we've saved a massive amount of time, and our deploys are now way faster than going from this like single gigantic images to these like kind of super lean ones that have just the dependencies we care about. Cool, so we have our test passing, we have our container built, now we want to deploy our service. So before you merge your change, we have a QA environment where every service has a QA kind of version of it running. And that's great for kind of very risky changes that you're like, I'm going to add a feature flag, but even if I do add a feature flag, I'm kind of worried that this is going to blow up, or maybe it's a change that it's really hard to test locally on your your Linux remote worker, so like you just need it in a real environment. So we have QA for that, and we built a new system recently where, historically QA was a shared environment. So everyone, if you wanted to test the same service, would say like, oh, I'm waiting for the service after you, let me know when you're done with it. And that's fine when there's a smaller number of engineers, but as some services become contention points, it's like, I really care about the payment service, and I really want to make sure my change doesn't break it, so I'm going to test it in QA first. But then you're waiting for someone else, maybe they need an hour to feel confident with their change, but now it's an hour I spent waiting that I couldn't do anything. So we're getting to a point now where you can run, we do kind of network intercepts. We say like, you were trying to hit the payment service, but we know that you wanted your own version of the payment service in QA, so we kind of hijack that request and we send it to a deployed version of your code, and that way you can see your local version of it, and you can say like, I want to run a load test against my version, and you get the benefits of QA where you can break it and it doesn't really matter, but you don't have to contend with other people. And so again, it's like, we want to encourage people to do this kind of fairly rigorous testing in QA, gain as much confidence, because if this payment service breaks in production, it's a big deal because people will notice. And even if it doesn't break production, it might block deploys or we kind of roll back. So we really want to push as much as we can, like we say, left in the development curve. So as much as we can statically, and if not statically, then before we merge code, so that we know when stuff goes to production, we have really high confidence that it's actually going to work. And it pays off. So we, at this point, end up playing 20 to 25 times a day of our payment service. It takes about 45 minutes, of which the majority of that is really just spent shifting traffic over slowly and checking if the new service, the new version is healthy. And so we do this pretty much without human intervention, because we can just define, these are the health checks I care about for my service, and they're really high fidelity because we've had years of operating this now. We know the kind of shapes of failures that we care about, and we can just say, deploy this code. If you see these alerts firing, obviously it's a bad change, and we don't even have to roll back anymore because we're doing traffic shifting. We can literally just say, whatever % of traffic we had going to the old version, immediately stop that, to the new version, immediately stop that and go back to the old version. And it goes from being, like a 45-minute rollout to like 1 second just to tee over the traffic, and then you're done immediately. So if there is an issue, you can mitigate it extremely quickly, and then that buys you time to put up a fix, redeploy, and then when you see the traffic shifting over successfully, at least you've passed it. And this helps us a lot. Like we pretty rarely at this point have failed deploys, and we do very rarely have customer impact. So I think we usually aim for something like at least 5 nines of availability on our payment service. And you just have to kind of stack these layers of defense on top of each other. So you have to have good types, you have to have good CI, you have to have good pre-prod testing, you have to have good traffic shifting. And so there are issues, you catch them as early as you can. And it helps us as developers, because then you don't have as much fear, because you just know there are layers that are set up to protect you based on what we've learned. Cool, all right, so that was how we're deploying code, and we can talk a little bit about like what we're actually running in production. So I kind of showed you that graph a little bit before about everything I can reach. So it's like, I know I'm starting from here, what is everything I could possibly touch? So what we do as well is we build a list of Ruby constants that we know that your entry point could reference. And when we're loading up your service, before we accept any traffic, we will literally obj.const get those, and we'll just say, bring them all into scope in Ruby, and there might be thousands of them. So that way they're like in Ruby's, it's actually they're live in code. Because what we really don't want is our first request to have to load an enormous amount of code, because that first user is going to have a horrible experience, and they're going to be waiting seconds, maybe even more, for all the code to load. So we load it all first, and then we start forking off workers, and then you get another benefit, which is copy and write page sharing in Linux. So it means that you might have 30 workers per machine, but you're not loading the same code 30 times, because they can reuse a lot of those pages in the parent process. So it means that you get like really good speed up, really good performance from the first request, but it also means that you haven't kind of massively wasted memory, which we find is one of our limiting resources. We just got everything onto 3.3.3. I was hoping to get us onto 3.3.5 by this talk, but there's an annoying issue with one of the gems that we need to recompile, so maybe next year I'll be on head. But we found the 3.3 upgrade really quite smooth, much easier than our 3.1 upgrade previously. And one of the main motivators for us to really invest in getting onto 3.3 was widget. So if you have not used it yet, please do. It is really impressive what Shopify has managed to put out. Like we have a kind of weird code base that we don't even use Rails. It's not even that similar to their code base, but we turned it on and it was like a 25-ish% CPU reduction, basically for free from our point of view. Like no special tuning, no issues with correctness. It's really like quite magical how well it works. And then as part of the 3.3 upgrade, we also caught a few bugs in Ruby that we reported and tried to, we got fixed. We're trying to be a bit better about that. So eventually our goal is nightly builds. So we notice these issues before they go live. Shopify does the same thing. I believe GitHub does the same thing, where you start participating much more actively in the community. And then that kind of benefits everyone here, because rather than we notice a bug, it goes into production release, you gotta wait for a backport for another version, or maybe they won't backport it and it has to wait for the next minor patch. We can just catch it as early as possible. And so we were kind of like very keen to get more involved in the community, because we found at least the performance benefits on widget really pay for itself. Not catching bugs and having to wait for backports is really helpful for us. So we kind of really want to participate more in the community too. Cool. So that's kind of like a little walkthrough through the development lifecycle. So you had an idea, you fix it, how does it actually go out, and then kind of what are we running in production. So thank you for listening, and happy to answer any questions.
Just wondering, with the way you're figuring out which tests to run, have you open sourced that as a tool that others can use? We
have not. To be honest, I think we probably wouldn't want to release it as it is right now. So it's a C++ program that hijacks the OpenSys, so we kind of preload it, like LD preload in the process. If we were to do it now, we probably would do something a bit more native and like modern in Linux, and maybe something like an eBPF, like actually track which, use the kernel functionality to do this rather than like a little bit of a hacky solution. I think we would like to rewrite it to be kind of more modern, and at that point, I think we'd be happy to share it out. But as of yet, no, we have not open sourced it.
Yeah, coming.
Hi there. I want to ask about tests again. So just in terms of measurement of time, not only the volume of tests. You said something about 2 million tests down to 2,000 based on the recursive check, whatever. I'm curious, what's the time spent in tests on average on a daily run for all your release cycles? And then how or did you use any other optimizations at the hosting cost to handle those runs, right?
Sorry, could you say that last part again, please?
Did you do any optimization from an infrastructure part to improve the time? I'm pretty sure what you're doing here is just based on the cost itself, which is AWS running time, not the actual volume of tests, but more the duration of the test, right?
Yep.
So.
Yeah, so how much time is actually spent in aggregate? I don't know the number. I know that we try to track for 10 minutes for people to kind of finish a CI run, even when we have like a full build where you have to run every single test. And we can just kind of elastically, well, we figure out how many tests we will run, and then we'll kind of elastically allocate a number of workers to kind of approximate a 10-minute run. So we don't know ahead of time exactly, but like we always try to aim for about 10 minutes. But I don't know, because that would be like 10 minutes roughly times the number of people pushing changes times the number of changes per person per day. I don't know the number off the top of my head. And then as for optimizing the tests, so one thing we are trying to do right now is get YJIT working in CI, but it's a very different shape from what YJIT was built for, because that was the same service that you just run for like an hour plus, and so it has really time to optimize code, whereas CI is a bit more of a very ad hoc, run this test, and there might not be a ton of shared code, but we're trying to experiment with it because we think there is potential to kind of, again, make the tests faster. So first thing is do less work. So if you can strip out tests, that's 100% time reductions. That's the best thing to do. And then definitely if you can make stuff faster, then do it. But yeah, it's really like by far the most effective thing was just filter out 99.5% of tests, because it's really hard to beat that through optimizing the runtime of the entire test suite. Just don't do most of it is by far the best solution.
I have a question. RSpec or mini test?
Mini tests.
Perfect. Right in the back.
Exciting talk, thank you very much. My question is about the deployment slide. First of all, the measurement of risky change. Is it Stripe specific, or maybe you have some recommendations about it? And secondly, I saw that production deploys are fully automatic. It happens 20-25 times per day. It's not very clear where is the place for stagement deployment.
Yep. So yeah, two parts. So what constitutes a risky change that would make you want to test in QA first? And then the second part about in production. Sorry, what was the second part again? Like when it goes into production, how do we, sorry, I can't remember the question. But anyway, for the first part, whatever that you can do that you could say feature flag, you would probably feel more confident about putting that into production without having to run it through QA first. Because if you can start by saying, like, I'm just not going to use this code part at all, then that's effectively the same as I didn't make a change. And then I can start with 1% of traffic, or I can start with my test account. And if that breaks, it's fine. I can live with that, and I turn it off quickly. And our feature flag fidelity is something like single-digit seconds between you make the change and when it kicks in. So you can feel really confident that I make a change, I turn the flag on, it blows up immediately because I see it in a graph. I turn it off, like it's done. So you feel confident about using that as a lever for being safe. So as part of this 3.3 upgrade, that stuff is a lot harder to feature flag on and off, because you can't, once you've started the process, switch between your 3.3 and like the previous version that we were using. So in that case, that we did a lot of QA testing first, because even if we say like we want one worker out of this like pool of workers to be on 3.3, if it gets into production and then it starts seeing failures, that would mean that like up until we kind of kill that worker, we roll back the version, it's causing errors for us. So that was an example of where we would feel we want to push testing into QA. So a little bit is personal taste of like what you think would constitute a change, but really it's just about like kind of what would be hard to roll back. That's the most important one. And then I feel really bad because I forgot your second question, but it was a good one. So does anyone remember?
Just asking, if a production deployment is full automatic, probably this blue-green happens kind of, let's increase traffic for 10% every hour or so. So the question is, does it really work this way? And if in this fully automatic scenario, it wasn't clear for me what's the place for staging deployment.
So yes, it is blue-green, pretty much every service. And so we just spin up an entire second set with the new code. And then within our service definitions, usually we have priority tiers of traffic. And so we set like service owners will say, this is my test mode traffic, it is the least sensitive one. And then in our payment service, let's say like the actual payment API endpoints are the most sensitive ones. And we kind of work our way up that list. So we start from the least sensitive to the most sensitive. And at each step, we shift over some set of traffic. And so you're blue-green and you're like very incremental. So you do like test mode, 1% first. And then you ramp that up to like 100%. And then you do like the next tier. And you ramp those over incrementally. So yeah, blue-green. And it gives us time to like really have confidence that changes are baking. And then as for staging, so every service, so we also define a set of what we call availability tiers. And so those are services that we consider to be, we kind of rank services by how important they are. So again, our payment services are most important. Maybe like a asynchronous service that has a very high SLA is like far less important for us, because if it breaks for an hour, that's fine, because we can just catch up later and like we didn't violate our SLA. And so for those ones, for everything in the kind of the upper tier, we mandate that those services use pre-prod, which is our staging environment. And the way pre-prod works is it's pretty much a copy of production, but scaled down. And we run a lot of synthetic traffic for those. So we would say kind of write test cases that would make a fake payment, and then they look at the response back and they assert that, like the amount is correct, or that if I delete it, it doesn't show up again. And we just kind of continuously run that traffic against our pre-prod environment. And service owners can't manually deploy into pre-prod. It happens automatically as you deploy production. So it's a prerequisite step. So you have this traffic running continuously, you deploy your new version, you assert that these preconditions are holding, or its post conditions are holding. And then when that has baked for a few minutes, long enough that you feel like you would catch the really obvious bugs, then you can move on production. And so that catches, again, like the most glaring failures. So like for the 3.3 upgrade, I don't think we really caught anything in pre-prod. But if we tested in QA, and for some reason like a different code path was taken in that synthetic traffic that we run in pre-prod, we would have caught it immediately there, and then it wouldn't have even gone to production. So we have the staging, and it's like it is mandatory for all most important services.
Do you use Packwork?
So do I use
Packwork
Packwork.
for modularizing?
Packwork.
I do not know what that is, so I'm gonna say no.
No.
How do you manage the different services that you have in Stripe in terms of like just the code base organization?
Okay. So we're trying to move to a pattern which is a lot more standardized. So we had like one giant API service, and over time we broke those up into kind of vertical slices of traffic, and that gives the teams ability to set kind of more higher fidelity failures for their deploy, some more specific health checks. And as we split that up, we're trying to be a lot more standardized in how we define those services. It is definitely one of those things that like you are untangling some of the lessons from history where things were done a bit more organically and you're trying to impose a bit more structure on it. So we don't use an external framework. But again, it's like we're trying to we are imposing a set of conventions on the code base to try and make it more uniform, so when you switch teams, things look the same. I wish we had the kind of convention that Rails does. It's like you could switch companies and it feels right because everyone does stuff in such a standard way. We did things a bit more organically, so it's not always that case. But we are trying to become more standardized.
I'm seeing that you and the team are very committed to monorepo. I'm wondering to know if there is any internal conversation or any voice rising or advocating to move more in the direction of microservices.
I would say, so I mean, even if you have to me those conversations aren't necessarily independent, because you could have a mono repo where you have many microservices. So I'm going to treat this as kind of two distinctions. So like one would be like, do we have a mono repo versus many repos? And then do we have kind of macro services or microservices? So I think we, as a company, are like fairly committed to the mono repo story, because again, we just find that is far better for our productivity. So there are rare cases that you have to sync code across the two. And it's kind of annoying because you have to like land the change in one, build it, wait for you to get a kind of an artifact that you can import into the other repo and use it. And it's like, it doesn't happen frequently, but I just wish everything were in the same place, because then I could make an atomic change where I add the new functionality and I use the updated functionality in the call sites in the other repo. So I think we are definitely shifting towards that mono repo story. As for the microservice versus microservice, I don't think we're going to go to a world where like things are micro. I think we tend to stick to like one service per team is where things are heading pretty organically. And we find out that like that gives teams isolation. I don't think teams would really benefit from having like many services. I don't think that would actually really bias anything. I think as long as we have kind of stricter interfaces around the services that teams do operate, that's sufficient for us to kind of keep code cleaner, to offload mental burden from these service owners to not have to think about, you know, how is my code being used by everyone. You just define your interface and that's sufficient for us. And the more you fracture your service graph, the harder stuff it is to reason about. It's like way easier if you're writing a test that everything runs in the same process, as opposed to in a test I have to mock, you know, the interface between services. If it were kind of related code and it's all in the same Ruby process, it's way easier to write and to reason about. So we tend to stick to like maybe one-ish service per team. And we're happy with that.
Okay, one last question. Let me.
How do you manage your database schema changes?
Yeah. So it's always possible that a change that you make gets rolled back. So I think that's the hardest one, because I think a lot of people are comfortable reasoning about backwards compatible changes. So, you know, I made a change to the schema, and then the new version of the code has to run with the old schema. That's fine. That's easy enough. The really messy case would be like, I make a change to the schema, and then we have to revert back, and now suddenly a kind of assumption of the code is broken. So we don't really have as much of a problem with that, we find, because people have baked it into their minds to know that, you know, if you're going to delete a field, the way that you do that is you ensure that there are no references to the field, and you can like very comfortably get to the point where you can prove, even with Sorbet, that there are no references to this field object. Once you've established that baseline, then you can delete it. And even if we roll back, nothing was using it anyway. So that kind of backwards incompatible schema change is fairly easy for us. Adding a field is easy because that's a kind of forwards compatible change. And then for something like renaming a field, for us, I think probably just don't do it, to be honest. If you needed to rename a field, you would just add a method that wraps that field, and then you can give that like a better name for the rest of the code base, and like that's sufficient. I don't think we would actually gain that much from like changing what's actually in the DB just for the sake of changing it, because what we really care about is the code interface as opposed to like the actual DB content. So we don't really run into the issue at this point.
Awesome. Thank you so much, James.
Oh, thank you.
It was like